What's good, math family? In this video, I'm going to show you guys how to find the missing angles of triangles using inverse trig functions. Starting this video out, we have to understand we are not using Pythagorean theorem to solve these problems. We're going to trig functions, so we're talking about the acronym SOHCAHTOA, because this is what we have to use to find that missing angle. Now, understand, family, these are just our sine, cosine, and tangent functions, and the other letters are just expressing the relationship. And the relationship is always based off the angle. So in this problem, this would be my adjacent side, this would be my opposite side, and this is my hypotenuse. So if we're trying to figure out what x is, I would need a relationship where it's the opposite over the hypotenuse. And when we look at our acronym, right, the sine function is opposite over hypotenuse. So now I go in here and I say sine x is equal to 2 over 30. And the reason why a lot of students get these type of problems wrong is because they don't understand inverse operations or just opposite operations. So let's say we had an equation x plus 10 is equal to 12. To solve using inverse operations, the inverse operation of adding 10 is subtracting. And this is how I would solve to get x is equal to 2. But when we go over here to trig functions and we're talking about sine, we are not dividing by sine. All right, that's not how we get the inverse. So to do it, we say x is equal to what? The inverse of sine, or sine to the -1 power. You'll see something like this, and it's on our calculator. So if you have a graphing calculator, you could put this all in at one time, meaning you'll hit second sine -1, and you'll put this in parentheses. Now, if you have a standard regular calculator similar to this is how we'll do it. We have x is equal to the inverse of sine, and we're going to turn that fraction into a decimal. So once I turn this into a decimal, I get 0.0, and we're going to round this off, 667. Now, for us to properly get what x is equal to, we're going to put this into our calculator, hit second, then sine, and we get our answer. And once I do that, I'm going to get an answer of x is equal to 3.82. So we can round this off as x is equal to 3.8 degrees. So we solved the first one. Now, when we put all of that together for our second example, this is what we're going to get. And remember, it's based off the angle. So now this changes. This is my adjacent side. This is my opposite side. And here goes my hypotenuse. So if I want adjacent, or opposite over adjacent, I should say, we're going to use tangent. So tangent is what we're going to use here. So we have tan x is equal to what? Opposite over adjacent. So we have 15 over 20, right? I'm going to reduce this fraction. So we have tan x is equal to, I want to say this is 0.75. So now to get x by itself, we're going to take the inverse, not divide by 10. If you divide by 10, you're going to get the wrong answer. So now we know x is equal to the inverse of tangent times 0.75. So once we simplify this now, what are we going to get? All right, we put our decimal in first, second 10, and what we get is x is equal to 36.869. So depending on what they tell you to round this off to, we could get an answer of x is equal to 36.87 degrees. So when we're talking about finding the missing angle of a triangle using inverse trig functions, math family, this is how you would do it. Please make sure you do not just divide. That is a common mistake. And if this video was helpful for you, smash the like button, comment down below if you have questions or comments for future videos you guys would like to see on our channel, or if you had a question on today's video. Thank you guys so much for joining Algebra 1 with Mr. Peters.